go over this problem. We've got the two functions, x plus 2. I forget which one's that. Is this one f or g? This is f, and this is x plus 2. And this one's g, x squared. We're going to take those two along with the x equals 0, the y-axis, to form a region there. We're going to revolve that region around the y-axis. At 180 degrees of that rotation, we'll be back here and look like that. So then our empty shell will look something like that. And where's our empty shell? Is it this conical spot up here or this down below? This down below. That's the empty shell that we're going to fill with cylinders, right? We're going to fill that with cylinders. Okay? So we'll do, if we're to chop this up in delta x intervals first, what would a typical cylinder look like? So a typical cylinder would look like, it would be what you would get if you took that and rotated around the y-axis. That would give you one of the cylinders that will fill this thing up. So when you rotate that around, you get something that looks like this. Okay? As delta x increases, as x increases through the delta x intervals, how does the cylinder change in the current interval? How does the cylinder change in the current interval? Does its height change? Does its radius change? Or both? You should be thinking the radius changes only. In the current interval, the height stays the same, the radius increases. Right? The radius increases as x increases through the current delta x interval. Okay? That being said, then what's our rate of change of volume going to be? She wants 2 pi RH. That's right? Because the radius is going to change by the amount of lateral surface area we have, this vertical surface. And do you remember, is that a changing rate? Even in the current interval, is that a changing rate or a constant rate? Do you remember? That one is a changing rate, right? That's a changing rate. Even throughout the current interval, as the radius grows, that rate of change even changes within the current interval. Okay, but that doesn't faze us because we're going to make the interval small, right? So when the intervals get small, that's okay. All right, so the question is, we've got to get the radius in terms of x and the height in terms of x. So come back here. The radius of this thing is going to be what? From here to here. That's the radius of this cylinder. And you need to recognize what that is. What is that radius? You should be able to recognize that that's simply the x value. And that's either curve, right? So that's the same value down here on this curve. So from there to there is x. From here to here is the same x. So this is key, that you can recognize that right there is just simply the x coordinate of a point on either curve. So radius is x. What about the height? The height then is of the cylinder is from here to here. Is that a y coordinate, that distance? Is that a y coordinate? No, because it doesn't go down to the x-axis, right? If this was all the way down to the x-axis, then we have a y coordinate. But really what we have is kind of a large change in y, right? So it's kind of like we have two different y's, and that distance is the change in y. So and how do we get the change in y from this y coordinate here to this y coordinate here? Yeah, so, right, exactly. It's going to be whatever this value of this function is, f of x minus g of x. And we know what those are. So 2 pi x, f is x plus 2 minus x squared. So there's our rate function. And so now how do we get a little bit of accumulation of volume? A little bit of accumulation of volume, or dV, equals, it's going to be the rate times dx, right? Given any change in x, the change in volume is going to be the rate of change times that change in x. And so then if we want to accumulate all the bits of volume, we're going to start from 0 to any value x, and we're going to take that rate, 2 pi x. Let's write that out. Here it is. Oh, that's not that. I'll just write it out. Here we go. It's rate of change. F of x is x plus 2 minus x squared. And did I do it right? Is that right? Nope. What's wrong? Gotta have something different. To represent all x values from 0 to x, right? X varying from 0 to x, x being the current value of x through which we've accumulated, right? And this then, for any value of x, represents all the values from 0 to x. Okay, so that's our rate, or that's our volume, right? That's our volume as a function of x. Okay, so then the other one was harder, so, but we can do it. Any questions on this one so far? Questions on using delta x intervals and those cylinders to fill?
Kind of about this, but it's like,
yeah.
So like, if they wanted you to do it up to like when you're doing like the current interval, do you have to use the accumulation function? Like the
Don't understand the question.
sigma.
Yeah, so we're conceiving this with delta x that we can see with our eyes, and so if you were really sticking with that, then you would use sigma. But then when we write this, then we're conceiving of those delta x intervals becoming very small. Does that answer the question?
I had forgotten how to do it if you asked for the current interval. That's why I was sorry. Yes, I did answer the question.
Are you sure? Okay. But yes, the way we conceive it is with delta x intervals that we can actually, see the width with our eyes. And if I was truly writing down the mathematics to reflect that, I would be using sigma. Yeah. Okay, so then we'll go on to same empty cylinder to fill, or empty shell to fill. Okay, but now we're going to think of that with delta y, and we talked about last time what happens when you use delta y intervals. When we use delta y intervals, something happens here that's different. Yeah.
In this case, you end up needing a piecewise function.
Yes, and we need a piecewise function because? What's that?
Or the inner rate is 0 up to 2.
Right, and so our rate function, we're going to have a different rate function, rate of change of volume, as y changes from 0 to 2 than when y changes from 2 to 4. We'll have a different rate function, right? So we'll do each one. So, and we can write that rate function then. We can write that piecewise. And if we've got the correct rate function piecewise, we only need one volume function, right? We can just use that rate function that's correct for all values from y equals 0 to 4. And we don't need a piecewise volume function because the rate function is correct for all values, right? It's just, so down here, so when we rotate this around the y-axis, we get this kind of cylinder, or cylinder that will kind of look like that. And what's the rate of change of this kind of cylinder? Okay, so as y increases through delta y intervals, what's changing in the current delta y interval of this cylinder? What changes? Height? Does the radius change? Only height changes, right? Height changes only. Okay, and so then as the height changes, what's our rate of change of that cylinder? Pi r squared. This area right here, right? This area right here, what I'm shading, is the same value as the rate of change of this thing as it grows in height. So that's going to be pi r squared. And so what's r? Again, you should recognize that's the x-coordinate. That's just simply the x-coordinate. But we need it in terms of y because this function is in terms of y. So what is x in terms of y? Since y is x squared, x is square root of y. Okay, so that's our rate function for y values from 0 to 2. What about from 2 to 4? Well, we're going to get a cylinder that looks like this now. And so it's the same thing, only the height changes as y increases through the current interval. Only the height changes, therefore the rate of change is? Right, so instead of a full disk of area, we've got a disk with a smaller disk missing, right? So we're going to do pi r squared for the outer radius minus pi r inner radius squared. Okay, outer radius is? It's an x-coordinate, and it's the same x-coordinate we had down for here. The outer radius stays the same the whole way, right? For both, so that it's going to be the same. What is the inner radius now, right? So what's the inner radius? But first and foremost, what is it before we talk about y's? Is it f of x? In its most simple, the most simplest way to describe that is it's an x, right? It's an x. It's an x-coordinate. But now it's the x-coordinate on this graph, on f of x, right? Now it's the x-coordinate on this graph. So this x equals, if y equals x plus 2, then x equals so y minus 2. So both these radii, you got to see, both these radii are just simply an x-coordinate. Now they're different x-coordinates, right? The outer one is the x-coordinate on the function g, and the inner one is the x-coordinate on the function f. Okay, so we've got, this is what? This is the rate of change when y changes from 2 to 4. This is the rate of change when y changes from 0 to 2. So we're going to piece those together. We're going to have a function that says when y is between 0 and 2, I want the rate to be this. And then when y is between 2 and 4, I want the rate to be that one on top. So I've already put that in GC, and I'll show that to you. So there's that first rate function. I called it R sub capital X. And then here's this second one. So in order to do a piecewise function, on a Mac, so I'll just type the whole thing again, just so you can see. You don't have to have the subscript. I just use that to delineate between the two rate functions for x and y, but you don't need to have the subscript. So you start it the same way, equals. When you get to here, if you want to do a piecewise function, on Mac, it's Control A. On PC, it's Control Shift A. And every time you do that, it gives you another line. So if I wanted more lines, I could keep going, Control A, and it give me a new line in my piecewise function. All I need is 2, so I just hit that Control A once. And now when I put this in, I'm going to put it in just like this. So we had pi radical y squared is the same as pi y. And then you're going to need if. Okay, in these piecewise functions, you need not a comma, but if. So you just type the word if. And then I'm showing here if, so 0 from 0 to 2. And then the new rate function is going to take over if 2 is less than y, less than or equal to 4. And that will make the rate function defined for all values starting from 0 up to 4. Is this consistent with what we just did? For that, what we wrote down? For the second rate function? Yeah, I'm just simplifying square root of y, quantity squared, as just y. Okay, so how can we do a quick test to see if these two rate functions, so here's the accumulation function for, using the rate function for x, and then here's the accumulation function using delta y intervals, or the rate function we use for y. What's a quick test to see if I've done this right? So how can I quickly make one check to see if I've done it right? I want everyone to think about that. So I'll put there's the image again. So what was A of x? A of x was using the concentric shells, like shells, each shell outside the one before it. And then the y intervals was like stacking pancakes, right? Stacking pancakes on top of each other to fill the empty shell. So talk with the person next to you. How could we do a quick check to see if all this work that we've done is correct? Okay, everyone talk about it. Think about it and talk about it. Hello? No, I'm not. I'm in class. I can't hear you. You gotta talk louder. Hello? I don't know. I'm in class. Bye. Okay. What do we think? So what would be one way to do a check to see if what we've done is correct? Yes? She wants to plug 2 into the volume accumulation function that we did with delta x intervals, and then plug 4 in for y, because now we're talking about filling the whole empty shell, right? So a sub x of 2 was going to fill our whole shell, so would a sub y of 4. So a sub x of 2 is 16.75, a sub y of 4, same thing. But the powerful thing about having the function is we can get a volume for any x value as x goes from 0 to 2, and then any y value as y goes from 0 to 4. But along the way that volume is going to accumulate to get to this value of 16.755 is going to be very different, right? So when you get to y equals 2 or x equals 1, you're going to have a different volume accumulated. because the shape is not symmetric x and y, right? But we know for sure when we get that whole thing filled, we ought to get the same volume. Okay, questions about your homework example? Okay, so let's do one more, and I'm going to leave all the work to you. That's what you can use the graph paper as you please. Here's the example. You're first going to sketch the region in the first quadrant, bounded by y equals x to the fourth plus 1, y equals 3, and x equals a half, 0.5. And then we're going to rotate that about the x-axis and get an empty shell by rotating that enclosed region around the x-axis. So make sure you have your drawing right before you go any further than part B. Make sure you're imagining and drawing this correctly. And then we're going to do it both ways. You're going to imagine a set of cylinders formed by delta x intervals, sketch one of those, determine the rate of change function and the volume function, and then do it again for cylinders formed by delta y intervals. But it's the same empty shell that you get by rotating around the x-axis. Okay? So for this...
Yeah. So y is up there. We have it's like 0.5.
Yeah.
0.5 plus 0.6. So it would be y of 4. We've got y plus 1. And where x equals 0.5. So y equals 0.5. X to the 4th. I wrote that. So y equals 0.5. Yes, but I'm just trying to subtract that initial point from it. So we would have y minus 1.065 times. So we've got now our radius times our height. So I was figuring out the y value at this point was 1.065. Yes. Yeah, I know. And I was having yeah, that's why.
Well, like between each one, like it's going. Yeah, it has to move along this.
Okay, so for delta y, your cylinders, you're talking about a delta y like this, revolves around the x-axis, gives you a cylinder something like that. As y increases, only radius increases in the current interval, right? Height doesn't change in the current interval. So as radius increases, we got the 2 pi rh. So the question is, what is the radius of that shell? What is the radius of that shell? Center of rotation is here. Y. It's y. The radius is, you got to recognize, that's simply y coordinate. Okay? And then what is our height of this cylinder? So from here to here. Is that an x coordinate? That distance, is it an x coordinate? No. It's a change in x, right? It's a final x minus an initial x. It's a change in x. So the final x is? Okay, but x and x to the fourth plus 1 are not the same thing. So we're going to start by just writing down x. We're just going to write down x because it's x for that blue curve, right? Minus the x of this, which is 0.5. So yes, this x is from the y equals x to the fourth plus 1 curve, but you don't write x to the fourth plus 1 in here. That's not the same as x. What we need is the same value as this x, but in terms of y. So how do I get that? You've got to solve that equation for x. So we've got y equals x to the fourth plus 1. And I need to get what is x in terms of y. First step, Subtract 1. Next step. Fourth root of y minus 1. That's what x is. X does not equal x to the fourth plus 1. X equals, according to on that curve, x is the fourth root of y minus 1. So there's our rate function for delta y intervals. Here's your rate function for delta x intervals. We know that's 95% of the battle right there, getting those rate functions. Then you can write your volume functions using integrals. Recitation today is anybody can go and you'll work on the homework for Wednesday. More problems like this.